Hi friends, in this episode we'll say about combustion, air requirement and fuel gas analysis. For combustion, following three things are required: fuel, oxygen and three T's. All fuel contains carbon, hydrogen and some amount of oxygen and sulfur. To obtain 1 kg of oxygen we require 4.35 kg of air, and for 1 meter cube of oxygen we require 100/21 is equal to 4.76 meter cube of air. Now we can see about the three T's. Time is the first T. For example, combustion of any fuel, sufficient time is required. Then comes temperature. The fuel should be at ignition temperature for burning. Different fuels are having different ignition temperature. Temperature at which the fuel starts to burn is called the ignition temperature. Then the third one is the turbulence. For complete combustion, the fuel and air should mix properly. By creating turbulence, the fuel can be burnt with excess air. Turbulence ensures the supply of oxygen to each molecule of the fuel and help for complete combustion. We require excess gas for complete combustion of any fuel. It is a stoichiometric requirement for complete combustion. Normally 15 to 20% excess air is required in coal-fired boilers. Theoretical air requirement can be calculated by this formula: 11 into 7.6 into C plus 34.8 into H2 minus O2 by 8 plus 4.35 into S divided by 100 kg per kg of fuel. This is theoretical requirement, but we have to give more air. Excess air supplied can be calculated in AC formula: O2 percentage divided by 21 minus O2 percentage into 100. Another method also is there. Excess air can be calculated in 79 into O2 divided by 21 into 1 minus CO2 minus O2. Or oxygen and carbon dioxide value you have to fill up. For example, if the dry oxygen reading in the fuel gas analyzer in the flue gas in chimney area or near chimney area, X% excess air is calculated as follow: 0.895 into X divided by 0.21 minus X, that is the dry oxygen in flue gas is 3%. Then we can calculate 0.895 into 0.03 divided by 0.21 minus 0.03 is equal to 14.9% excess air we are using. In this slide now we can see about the effects of impurities in the coal and how it affects the combustion. Do not forget to subscribe and share it with your friends and colleagues. Put your like and comment in the comment box. Also, any question you require, please put it in the comment box. High ash content along with minerals in coal will lead to incomplete combustion to form unburned coal with sticky material called clinker. It is a non-combustible residue fused into an irregular lump that remains after the combustion of coal, which used to block the outlet chute of the burnt coal to the submerged ash belt conveyor. That is when the coal fire boiler through crushed coal over the travel gate inside the furnace, it will burnt into ash. The combustion is complete. If the coal is having ash content and some minerals, then it will form clinker. That is incomplete combustion. That will block the chute going to the submerged ash belt conveyor. The sulfur content in coal is there. It will lead to sulfur dioxide and sulfur trioxide formation, which further reacts with moisture content in the atmosphere to form highly corrosive H2SO3 sulfurous acid, which will foul and corrode the equipment. We have efficiency loss in the air preheater, increased stack capacity that you cannot see the gas going outside the atmosphere, and the formation of particulate matter 2.5. That is very tiny particle or droplets in the air that are tuned of microns or less in width. It will cause an adverse effect on health. Also, it will lead to acid rain. If the concentration in the atmosphere is high for the sulfur percentage in the coal or any fuel. Normally the typical range is around 0.5 to 0.8% of sulfur. It affects clinkering and sagging tendencies. Sulfur corrode the chimney and other equipment such as aerator, economizer in the flue gas path while exchanging the heat. It also limits the flue gas flue gas temperature exit to the chimney. To avoid this, we have to keep the flue gas temperature above 155 to 165 degrees centigrade while entering the chimney, or should leave the chimney more than 150 degrees centigrade, as sulfur dew point is 143 degrees centigrade. Moisture content in coal promote partial combustion and enhance smoke formation. It also reduces relative efficiency of heating, and moisture content is there, calorific value of the fuel or coal is less. Now we can see about the fuel gas analysis. It can be measured by an apparatus called Orsett apparatus. It's an apparatus for gas analysis that consists of measuring burette, a connected series of pipettes containing selective absorbents, and usually a combustion pipette. Now we can see how to use Orsett apparatus. This is schematic diagram of Orsett apparatus. This inventor of Orsett apparatus by inventor named H. Orsett. He invented the Orsett in 1873. Is an apparatus to measure carbon monoxide, carbon dioxide, and oxygen using some chemical absorbents. This is the arrangement of the Orsett apparatus. This is a rubber aspirator where with the clamp we can connect the flue gas hose. This is a measuring bottle, leveling bottle. This is a burette which is graduated, filled with water, also jacketed. Outside is also filled with water. This is the first chamber where caustic potash is there with the isolation wall, and next one is having pipette is having alkaline pyrogalol, and the third one is having ammoniacal cuprous chloride. And this is one more vent for this is a three-way cock through which we can admit the flue gas to get absorbed in the pipette. And this is the graduated burette. These are all connected in series. Now you can see how the Orsett apparatus works. I connect the tube to this inlet. Open the three-way valve. First you have to admit flue gas in the caustic potash pipette. You have to open this valve using this leveling bottle. When you open the three-way valve, you will get absorbed the water. I'll fill it with gas. Then when we have to raise the bottle so that the water level will increase and it will push the flue gas to this pipette, it will get absorbed. We have to do the raising and lowering of this bottle anytime. Then we can see the rise in the level, which is the amount of carbon dioxide. Then we have to go for oxygen using the alkaline pyrogalol. Then the third one we have to see CO absorption in the ammoniacal cuprous chloride. This is a method. First you have to admit this one. After the absorbent is completed, then we have to close it. Then we have to open this one, and then last one we have to use this CO absorbent. So when there is no bubble is coming and all gas is absorbed, then we can stop and we can see the reading or the CO which is coming on the last. The value of carbon dioxide is 15%. and CO is around 0.2 or oxygen is 4% is excess. That means a very good combustion, complete combustion is taken place. So we can ensure it that a boiler is running and coal is used as a fuel. Excessor is completely used for complete combustion and no clinker formation. CO also within limit, so that we can see the flue gas analysis using the RSAT apparatus, which is accurate and is manual one. You can also measure the dry O2 content in the instrument analyzer near the flue gas analyzer in the entering chimney. Hope you might have understand the combustion, flue gas analysis, and impurities in coal which affect the combustion. Do not forget to subscribe and share it with your friends and colleagues. Put your questions in the comment box. See you in the next episode with LPG. Thank you very much.